In this video lecture, we will discuss a formula for the error bound in Simpson's approximation. And previously, we have learned the following formulas for the error bounds in trapezoidal and midpoint approximations. So we expect something similar in Simpson's approximation, and that's exactly what we're going to get. Almost. Well, I mean, we'll get what we expect, almost. And the formula looks like this. So we're going to have the E sub s representing the error, and it will be bounded by, I'll use a different letter here. Instead of K, I don't want to use M or L, so I'll just use letter. What's a good letter? Yes, let's just go with lowercase k. And we're going to have b minus a to the power of 5 divided by 180 and to the fourth. So a and b are still the limits of integration, but what is lowercase k? Lowercase k, it's the upper bound for the fourth derivative of the function f. And the ways we're going to be using these formulas are exactly the same as before. So let's go ahead and try this example. We are going to find the upper bound for the error, and we're going to be using this formula. Where a is -3, b is 1, n is 2. So to find k, we're going to find the fourth derivative. So f of x is 2e to the x, and this is a function whose fourth derivative will be exactly the same as any other derivative. And because this function is increasing, we know that it will reach its maximum on the far right side of the interval on which it is considered. So this is where it's minimum, this is where it is maximum. So to find value k, we're just going to throw 1 into the derivative formula, so k is equal to 2e. And now we're going to compute this bound by simply plugging in all these values. b is 1, a is -3 to the power of 5 divided by 180, and to the power of 4 is 2 to the power 4. And I'm going to simplify this a little bit before I throw it in the calculator. So we have 4 to the power 5, and here we have again 180 is 2 times 90. 2 times 90 is 2 times 45, and we have 2 to the power 4, which is the same as 4 to the power 2. So I'm just trying to simplify it as much as I can. We have 4 cubed here. We divide it by another 4, we get 16. So we have 32e over 45. And I'm just going to put it in the calculator real quick. And I got 1.933. And here we have to round up to the nearest 100. So I'm going to round it up to 1.94. And this is the largest error that we can get by using the Simpson's rule on this interval. All right, so let's try another problem. What is the minimum value of n? And to answer this question, we're going to start off with this formula. And we're going to set it up as an inequality. In order for us to achieve certain accuracy, we can guarantee it by making the expression in the middle less than 0.01. And if we focus on this inequality now, we know all the ingredients here. A is -1, B is 3, and of course we don't know. But k, to find k, we're going to find the derivative, the fourth derivative, and actually the upper bound of the fourth derivative. So the first derivative is 20x to the fourth. The second derivative is 80x cubed. The third derivative is 240x squared, and the fourth derivative is 480x. And again, we got lucky. We have an increasing function, passes through the origin, so it gets its minimum value on the left and its largest value on the right at 3. So k, we can set k to be the fourth derivative at 3. So 480 times 3 is 1440. Now we can solve this inequality for n. The first thing I'm going to do is I'm going to flip everything. Including the inequality. And now I'm going to isolate n to the fourth by manipulating this inequality. Everything is positive, so I'm going to multiply everything by k b minus a to the power fifth and divide everything by 180. And since n is positive, we can just take the fourth root of both sides. So this is the expression I will be working with. And we're going to replace everything in. So instead of k, I'll put 1440. B is 3. And I'm not gonna try to do it by hand, I'll just throw it in the calculator. This time I'll just use Wolfram Alpha, so I'm just gonna raise everything to the power 1/4. That's the same as taking the fourth root, and inside of the radical I'm gonna type it up. So this times 4 to the power fifth, and we're dividing by 180 times 0.01, and we got, let's double check, so I'll just press enter. 11440, 4 to the fifth. Yeah, it looks right. So the answer is 30.8. But remember, we're doing Simpson's rule, so not only we have to round up, we have to round up to the next even number. So the answer is 32 is the smallest value of n that will guarantee us this accuracy. So we discussed the formula for the error bound in Simpson's approximation and how to use it in 2 different ways.